Okay. As I mentioned, so we're going to monitor three things. One is the logs, and another one is the traces, another one is the metrics. So for the Grafana stack, that usually, or they will call LGTM stack. So L stands for Loki, and G stands for Grafana, and T stands for Tempo, and M stands for Mimir. So Loki is nothing but it is to collect the logs. So where from your application you can ingest the logs to Loki, and you can visualize in the Grafana. The same way for the distributed tracing, someone might be here, Zipkin, Zager. The same thing, it is developed by Tempo, which is the same inspiration of the Prometheus and Loki. They developed the Tempo also in the same way. So I will explain in detail later. The Mimir, so everyone will be knowing Prometheus, but very few people will be knowing about Mimir. So if you are worked with the component called Prometheus, the Prometheus is not a scalable system where it can run as just a standalone service. So we cannot run as a distributed system. So it is one of the big drawback if you are using Prometheus. So you may face a single point of failure. To address this one, so Grafana developed the Prometheus compatibility system. It means that wherever you are using Prometheus, you can replace with the Mimir. Yeah, this all things open source. Yeah.
This Thanos, CNCF2 is compatible to Prometheus. Same like.
Correct.
Same like Thanos, right?
Yeah. So Mimir is not completely replacement of Prometheus. So mostly they will be using the combination of Prometheus as well as the Mimir. Let's say in some cases, you need to pull the metrics. In that case, they will be using Prometheus as an agent. Let's say it is just a simple agent where it will be scraping the metrics and pushing to Mimir. If your system is capable of pushing the metrics directly to the Mimir, then you can use directly Mimir. So combination, I will explain in detail one by one. Yeah. So yeah, so I'm going to touch upon today the OpenTelemetry collector. As I mentioned, one of the agent. There is a, let's say, instead of you writing three different things, let's say you have to instrument the metrics, you have to send the logs, you have to use a prompt tail. To send the traces, you have to use some other agent. So instead of using different agents, so there is one tool called OpenTelemetry collector. So this OpenTelemetry collector will be acting as an agent. So now, regardless of any tool you use, so every observability platform, let's say even Datadog or New Relic, they're trying to adapt the OpenTelemetry collector as the standard things, or they are changing their observability platform where it is compatible with the OpenTelemetry collector. Because today you use New Relic, might be tomorrow you will change something else. It means that from the application point of view, you have to modify so many things that is a huge headache. They can't do any migration. That is the one reason they are bringing up one of the common collector, that is the OpenTelemetry collector. This one also we'll see in detail in the demo. Okay, as I mentioned earlier, so what is the main advantage when we use the this Grafana stack rather than any other tool? Let's say if you take majority of the current monitoring system, so for monitoring might be mostly they use a Prometheus. For logs might be they using Elasticsearch, and then for the distributed tracing, they might be using a Jaeger or a Zipkin. So if you see, there is no correlation between these tools. It's individual components or individual tools, the focusing on one particular solution. So with that, if let's say if you want to connect all these three dots, because your application, let's say as we seen in the slide, you find something issue on the metrics. From the metrics, you should be able to go to logs. From logs, you should able to go to the traces. But with the common other systems, you have to navigate multiple places, and you can't effectively achieve the MTT or so mean time to reduction. So those things it is very difficult to achieve in the other tools. But whereas in Grafana stack, this correlation is inbuilt, it is there. So I will show you that one also in the demo. So as I mentioned, okay, this is the one I want to highlight. Currently in Rakuten, our team, what kind of a problem they faced and why we choose this Grafana stack. Our system, if it in my current team, what's happening? We are using multiple components. Let's say we use a GCP, you use a Rakuten One Cloud. We use the few things in the container as a service, which is provided by again Rakuten One Cloud, and we have a bare metal servers, we have a virtual machines, and so many things. So let's say if you are using in a Rakuten is providing its own monitoring system, but with that monitoring system, I can't use for GCP. So let's say, okay, for GCP, if I use the GCP monitoring itself, then again, let's say sometimes what's happening, the few microservices from the on-prem, it is talking to GCP or the vice versa. So there is a disconnect for each and every, even though I belong to a single team, but my application is scattered into multiple infrastructure. We are facing different kinds of issues. I mean, different kinds of a solution for each and every component we use. So it's very, very difficult to maintain, as well as you will not achieve the same whatever we highlighted earlier. So because of this reason, what we have decided, so we developed the centralized platform. As we can see, regardless of whether you run a GKE or if you are running your service in RIAS, it doesn't matter. So what we'll do, either we'll use an OpenTelemetry collector, or in few cases, we use the individual components. Let's say, for example, if I am running my services in GKE, I will be installing Prometheus as an agent. This Prometheus agent will be scraping the metrics and it will be pushing to my Mimir. The same way, if I am running a virtual machine, again, this Prometheus will be, the Prometheus will scrape the metrics, then it will push to Mimir. The logs also same thing. It will send to Loki, and all things we can visualize from Grafana. So for distributed tracing, we are currently using OpenTelemetry. And we are, as I mentioned, we are exploring to next level, where for the to push metrics as well as push logs to use the OpenTelemetry collector. So I will show you that example also. And another thing, if you see those, let's say for setting up the alert also, since we have centralized this platform, I no need to go and create a separate set in different systems. Let's say if I use the Rakuten provided monitoring system, then I have to create alerts over there. Then I have to repeat the same thing in GCP. I have to repeat the same thing in if I use some other cloud also. But with this approach, we centralize the alerting mechanism also, and from a single place, we are able to monitor everything. And the major advantage of this one, so all these three components is compatible with the object storage. It means that you don't need to rely on your file system. You can push to any object storage. Let's say if you are setting up in GCP, then you can use Cloud Bucket. And if you are using AWS, then S3 Bucket. So it's compatible with all major cloud providers. But here in Rakuten itself, we have a storage as a service. We are using that feature, and we are storing all these metrics, logs, distributed tracing, everything into the storage as a service. As I mentioned earlier, so since we centralized everything from this centralized place, we are using Alert Manager. The Alert Manager will be sending notification to different channels. So this is the one of the main problem we faced. So with so many monitoring systems, then we streamlined into single place, and with this all three, we can able to run in a distributed manner. That is the main advantage for us. So we are able to easily scale up and we are able to maintain this infrastructure. So this data observability platform, so this one I will cover in the last portion. So as I mentioned, first we'll see this components, how we are effectively used, and we have in our team also, we heavily depend on the data, and we are, so we have this setup, and we also have so many plans how we can integrate with the platform. So without touching the other component, if I explain how this can be adapted for data observability, it will be a bit confusing. So I will come back after the demo. Yeah, so before going into demo, just I want to check with, is anyone having any questions as of now? It's open source. Whatever we highlighted here, it's all open source. Yeah, community version, yes. Okay, if no questions, then I will proceed further. So first I will, as I mentioned, so with after we done so many of integration, I will show a few dashboards so that we can think, you people also can think of how we can centralize and how effectively we can design the dashboards. After showing few of our dashboards, then I will go to the demo. So first thing is if you see, this is one of the component. It is called the node exporter. It is just an agent where you have to, let's say if you are running in a GKE or if you are running the virtual machine, this component has to be installed. So this component will be pushing the metrics to Mimir. So after pushing to Mimir, we can see very detailed information about your server. So if you see what's happening on your disk, CPU, memory, network. So there are a lot of things will be available with the single agent called a node exporter. You can see very detailed information, you can get it. And for example, this is one of the server which is running on our Riaz machine. If I show as per this slide, if you people remember this. So here we'll be running Prometheus. The Prometheus will be acting as an agent. It will just scrape the metrics. It will push to Mimir. Yeah, so there is a one option in Prometheus. There is called a remote write. So with remote write, you can push all the metrics to Mimir. Yeah, so and okay, I closed the other tab. Correct. This data source is the Mimir data source, not the Prometheus data source. So I shown earlier one of the virtual machine. You can see I can able to visualize you can see it is the GKE nodes actually. So as I explained earlier, I installed the node exporter on the GKE cluster. It will scrape and we can see all servers we can see here. The same metrics, whatever. So it means that regardless of where you are running a server, it doesn't matter. It's just the component and you have to push the metrics. So it's another kind of a visualization with this using the node exporter component. This will very helpful. Let's say it will give the visualization of all servers integrated with this observability platform. The main advantage of this one, let's say if you are handling with a bunch of servers, if you are monitoring this, so you want to sort out based on the CPU, or you want to sort out based on the memory used, disk used, or disk read. So whatever maybe you can easily sort and you can see, or you can scroll wherever you can see this red and it means something wrong. So you can see all servers in this list. And again, it's again a detailed explanation of whatever server you select from here. It will show you the detailed of that particular server, again, the CPU, memory, all these things. So it's, again, it's, let's say, whatever may be, as said, in data side also, majorly we use like a Couchbase, or you might be using a RabbitMQ cluster, Kafka cluster. So those things, if you integrate here, whenever you feel that you hitting with the CPU and memory, so easily you can come here and you can see where is the problem is. This is, I want to show a few more things on the Kubernetes side. It means that let's say the GKE cluster. Again, it's responsible for Prometheus only. So Prometheus will be scraping the metrics related to Kubernetes, and it is pushing to Mimir. So this is the API server statistics. We can see how sometimes if you feel that your API server is not scalable, or if you're facing some problem, then we can see and we can take a look. There are a lot of metrics will be available. Again, it's another view. Let's say it's a global view of your GKE cluster. You can select the particular cluster, for example. You can easily see how many nodes it is running. It is a global, let's say you are running a 3-node GKE cluster. You might be span with, might be, let's say, 4 CPU and 16 GB of RAM, and you deployed few applications. And this is the global view. You will know how much resource you left. Let's say part of this one, you can see as per my application I deployed, still I have this much limits and request. So we can easily find it out. This is for CPU and this is for memory. And again, it's how many nodes, how many namespace you are created, how many parts it is running. So again, you will get a very detailed information about your GKE cluster. Again, it is another visualization about the CPU, memory, all these things. So it's another kind of a visualization where it is the namespace-based visualization. Let's say if you are running a cluster in a multi-tenant mode, and if you want to see the CPU and memory used by the namespace wise, so that also possible. So you can select the particular namespace and you can see how much CPU and memory is used by that particular namespace. And again, number of pods running on that namespace, deployment, replica set, this all things you can visualize from here. So this is again one more kind of a visualization. It is for the nodes that we can run. We can see on each nodes. Why this visualization is very important. Sometimes what will happen, if you are not handling properly on your affinity and anti-affinity, what will happen, all your pods may go to one single server. Even though you run a bunch of cluster, what will happen, sometimes all the pods will go to one server. Then you may see, even though you have so much of CPU and memory on the other nodes, sometimes it will not, scheduler will not work properly. So always, whenever you're deploying your application, you should handle this affinity and anti-affinity properly. By the time, this will help you that whether each and every node, the pods are distributed properly. Yeah, in Grafana, yes, correct. So that I have that also. I will show you where we can download all this. So this is a pod-wise metrics. Let's say we've seen sometimes we don't, let's say as a application developer, majority times the others might be for the whoever is admin, but as an application developer, so what more I will be interested, how much CPU and memory is occupied by my application. It means that we have to view the pod wise. Let's say I selected one pod, we can see how much CPU and memory is used by that particular pod. We can see how much CPU and memory is we allocated and how much we occupied. and the CPU and memory of that particular pod. So the network bandwidth, all things we can visualize from here. So this will be more helpful when you are working as a developer. Yeah. Okay, this is one of the example. Let's say, as I mentioned, my application will be running from KE as well as from the virtual machine. Regardless where you run, let's say this is one of the Java application. I would say it's a Spring Boot application. From Spring Boot application, there is we have to, when you are building your application, there is a one component called a micrometer. So we have to build your application with a micrometer. And if you deploy that, let's say if you are deploying in GKE cluster, there is a one thing called a service monitor. If you deploy service monitor as long as with the micrometer, then the service monitor will expose the metrics and it will be scraped by the Prometheus. So if you are written a Java application, how your heap memory and all these things, you can see a lot of things. So how many threads you are generated, how much log event you are generating, what is the event, let's say whether you are generating an info log or error log, those things you can visualize from here. It is the, if you are using a Java application, then it will be very much useful to understand your heap size and the non-heap size on everything. Again, it's another view. Let's say from the same microservice, let's say you might be exposed with some endpoints. So based on the endpoints, so we are just counting the number of hits and how much milliseconds it's taking. So those kind of visualization is possible. So again, it is the instrumentation of your application. It will be very helpful to understand that. So you can see that whether it is generating 200 or it is generating 500 or 400. So you can easily understand what's happening in your application. Yeah, API endpoints monitoring this. Again, it's a one more view on the in the Spring Boot application. Again, it's very in a different way we are visualizing. Yeah. Okay, this one I will come later. This one is nothing but majority will since I belongs to SRE team. So one of my primary goal is to work on to show the application's SLO and what is my error budget. If you are familiar with those things, so our system is scattered into multiple places. Let's say for batch, we have to calculate the batch system and how much success failure ratio. Actually, if you see this one, it is actually coming from database, this metrics. So that is the one advantage of the Grafana. I will show quickly. So you can see this is coming from the database actually. I'm firing this query and this one. This is the another big advantage of the Grafana. Grafana has a lot of data sources. So one of the data source is the MySQL DB. Yeah. And this one, this things is the first one is coming from Prometheus. Actually, the second one is coming from the Loki logs. So that better I will show you on the demo.
Going back to the previous one on the application, also Spring Boot.
Yeah, Spring Boot app, yes.
Does it merge with the application log with the metrics? How easy is that?
Okay, 1 second. I will open this one, right? This one, how to add this components into my application, how to scrape, right?
Does it merge with that?
Yes, correct. That one I will explain. So usually what will happen, you have to say, there are components, as I mentioned, we can use OpenTelemetry or a prompt tail. So you have to run one agent, either prompt tail or the OpenTelemetry collector. There you have to mention the paths. So from which path I have to take my logs, then ship it to this one. So if you're running in GKE cluster or some other Kubernetes, so usually the prompt type will be running as a daemon. So it will scrape all the pods logs by default if you're exposing to std out. Yeah.
Different dashboards has different. For example, Java has
Yeah.
they configure that something will be inside that block exactly based upon the everything data or whatever.
Actually, you can. It is on the scraping level. So it means that when you are exposing metrics, this part I doubt, but usually all the metrics you can configure on the Prometheus which metrics to scrape, which metrics to drop. But mostly the application will expose all the metrics. So let's say, but actually it is a different agents. For example, to observe your server, you have to install Node Exporter as a different agent. Let's say to instrument your Java application, you have to pack the Java application with the micrometer, this one. So you can control only on the Prometheus scraping side. So which one should scrape or which one not to scrape. Yeah. So is it clear now? Correct. Yeah. 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 So you mean to say, is there any inbuilt agent? It can do the. Yes, correct. So usually there is a one library we need to include to visualize your Java application. So it is for Java, it is a micrometer. The same way for each language, it's providing one component. Might be they will provide as a Prometheus agent itself few applications. So yes, we have to include one library. Then only this all things will happen. Yeah, micrometer. Yes.
So those calls methods, in our unit, actually we have set the application development. They have written some methods. Typically, suppose I'm processing our basically supporting the idle letter process. So when they are processing the idle letter part job, it generates the data, then to push system. So that push data we can actually push again by the time the event has already occurred.
Push gateway. In the case, yes, push gateway.
Yeah, yeah.
The job is running during that time, we will also be.
Any thoughts on continuously on Spark applications?
Suppose if the Spark is continuously running, then you can take any metrics is available. For example, now the OpenTelemetry development is happening very good. Okay. So instead of the Spring Boot, we are talking about micrometer, but the micrometer only generates the Spring Boot related metrics. But the OpenTelemetry can actually gather your traces, metrics, and logs everything. Explore and
Thanks.
Another script for another log our user of that also look another. And
Prometheus has a plain language, plain HTML program. For example, if you see in a Python, you have a Python plain. So using a Python plain, suppose for running this program, the Python plain you can use the method I need to pass. You can generate a matrix. Like there are case lines. But Java, yes, that's what Java. So, yeah, that is, they have the plain available. But pushing a matrix, they expect in certain matrix. It's like a big group, follow that the same. Every matrix is having a record type, against type type or the constant type. Not change the type. Same type with another cascading from the protocol definition. The intent developer they could follow follow help state exact and the type of the matrix. They are following.
To end the discussion, just experience. Do you use this or have you used any other providers? But is it helpful? I'll just name one, Century. Do you like that better? Okay, as in one of the other tools is Century, right? So
OpenTelemetry.
So for the application blocks, I think that Century is actually not bad. It's just my opinion. Oh, yeah. So that's why I'm asking whether anybody has the experience with it.
So I want to know the logging part.
Yeah.
Predominantly people are using India, but Loki is very good. I use because India case, every logs are stored as a text. I mean, log wants to be just binary part. If I am storing 1 GB of log, so it has to store binary and on top of that you do inventory text. That creates more load. But Loki is inspired to. That means he just take the labels and whatever marks are coming, attach the label and put it in. Loki is doing. Basically, the logs are compressed. Suppose if I have only the log, I compress it to
Sorry, I think we have another half an hour for the Q&A. We'll talk about, might be I will complete this, sorry. Yeah. Yeah, I have only 8 minutes to go. Yeah. Okay, this, okay. So just I will highlight you, this is the place where you can play around. Let's say this is the play.grafana.org where you can have a lot of dashboards already available. Let's say this log, this dashboard is just because of your access log. From access log, actually you can develop a dashboard, something like this. So this is the place where you can find, so whatever I highlighted, all these dashboards you can find from here. There is a Grafana/dashboards. Another advantage of using the Grafana, where you can, let's say if you are written rules, you can visualize in a single place what's happening to your system. Let's say I have written a Loki rules, I have written a Mimir rules, I have written a Prometheus rules. This all rules can be visualized from Grafana easily under alerting and alerting rules. The main advantage is that you can just see which servers and what's happening with these labels and all, you can easily find it out. This is the one. So there is one more thing called a Grafana alert. If you are creating, there are two alerts. One is the creating alerts in the Grafana itself and writing on the alert manager. Alerts, and if you are linking the dashboard, you can see something like this. If it is okay as per your threshold, it will show green. If it is broken, then it's something broken heart. So yeah, this is the demo application. I think already I'm running on my local. Yeah, this is the one of the demo application. Let's say there are a lot of examples. If you go to Grafana GitHub, there you can see a lot of examples. This one is nothing but if you search on Hello Observability, you can find this one. You can design your dashboard like this also, based on the endpoints, how many things you are getting. Why I'm highlighting this, let's say you no need to worry about much. Let's say if you want to build a dashboard, something like this, you observe this dashboard and go to edit, and you can see how they set up. So you can easily set up the similar way. Whichever panel you like, you can do the same thing. So this is the logs. It is integrated with the, as I mentioned, all components. You can see the logs also part of your dashboard. The same thing they given for the same example, which I am running on local, we can visualize something like this also. Okay, this one, let me close. This is the actual demo I want to show. I am running one of my application, a demo application, which is running on my GKE cluster. From that GKE cluster, as I mentioned, I'm pushing the logs, I'm pushing the traces, I'm pushing the metrics as well. Let's say, for example, okay, I missed this. Yeah, for example, this is this one. So there is a one, again, there is one component called Grafana Observability. You can find it on the GitHub. They given a clear instruction how to deploy this application in a Kubernetes cluster. They use a Helm chart. So if you deploy this, for example, let's say I deployed in my GKE cluster. From there, I'm pushing my logs using OpenTelemetry collector. I will show you how we can do this integration. Let's say it is exposing multiple labels and filter. Let's say I'm selecting one of the services. It has multiple services. You can see it is actually a very big application. It has multiple components. It has a card service, ad service, so many things. So if I would be able to see the logs. As we seen here, the one of the big advantage of this one, right? You can do the live logs also. It will be keep rotating whenever if you want to troubleshoot your application along with this one. You can easily monitor your logs. Let's say if you want to find, if you want to grab some word also, it's very easy. Let's say if I look for something called error, I think there is no word called error. So let me remove this. Something called I have called, let's say I type called. So you can see, so whatever word you want to search is easily you can search. As I mentioned, this is the correlation is happening. Let's see. So I integrated the logs to traces. It means that the traces will be going to tempo. If I click this tempo, we can see the detailed view what is happening on your application. So if I see, this is the node graph, how this particular call is going. Yeah, this is the main advantage of using this kind of a thing.
So how does it work? How does Grafana know that this is the trace ID of them?
Okay, so when we integrate the OpenTelemetry collector, so actually there is a format to generate your logs along with the trace ID. So something you have to expose. Here you can see this is the log format they are following. If you see here, let me, okay. I should have close button here, something wrong. Okay. We can see the trace ID though. So we can see the trace ID here. And something we have to configure, let's say when you are configuring your data source, something we have to link this. Example, I will show quickly. If I go to connections, if I go to data sources, then let's say Loki. So this is the place I'm searching. I'm mentioning that look for this particular word, then redirect to tempo. Whatever you find, then value, redirect to tempo. So if you configure something like this, then from there you can go to tempo. So component, yeah. So yeah, so I will quickly show. Let's say, for example, I want to get the traces, I mean, basically a request, which is greater than something, 100 millisecond or whatever may be. If I go here and if I fire this query, so we are getting a lot of traces here. So for example, I take the highest one. Let's say, for example, if I take the, so actually, if you see, it is a very, very big call. So it is very, very common that if you have very peculiar system, so you will have n number of calls. You can easily understand which component is taking more time, and you can drill down on that particular application. Here, if you see the node graph, you can see how the flow is happening actually. So this is the very big advantage if you are integrate with the traces, and how easily we can you can write a lot of trace QL also. You can do the instrumentation in better way. So this will help you easily where the problem is. Let's say if there is a call to the database, you can easily find this is a call to database and this is taking this much time. So you can troubleshoot very easily. So this is the, again, with the distributed traces, just I was showing, I created a sample dashboard where you can generate 95th percentile. So it means that it is the how much 95, how much in average your each and every request is responding. In my case, it is returning 26 milliseconds around. So you can see that graph also. This is because of the distributed tracing. This example, just let me generate. Okay. So this is the application, one application I showed in GKE. The same way I just deployed one dummy application into our cluster, which is on the on-premise environment. So with that, it started generating a simple dummy application. Let me see, I'm getting some traces. Okay, so within last 5 minutes, I was able to get these logs. Let me run. Yeah, so if you see, I can see that some error here. If I extract this error, then again, same thing. If I click on tempo, it is taking me here. Right? If I go here, we can see what is happening. If you extract one by one from where this is generating, you can see it is coming from this application and from agent, everything, the resource. And finally, if you see that this is generated by the actual Java error, you can see that particular Java error. I think this one, let me, yeah. Yeah, so as majority of the question will be how to do this. So I will show you a sample configuration. It is very easy to integrate this components. As I mentioned, so we can use a OpenTelemetry collector. So OpenTelemetry collector, since we are interested in three, so we have to do three things. One thing is that if you see, one is for the traces, it is this one, this one. This is for the metrics. As I mentioned, we are writing directly to the Mimir. And this is for the Loki, where it is sending the logs. And this is the OpenTelemetry collector. We can run OpenTelemetry collector in multiple waves. The one I shown, the first demo in a GKE cluster, I deployed as a deployment. It means that the OpenTelemetry collector will be running in a common place. The applications will be sending metrics to that common collector, and we are handling that. The another way currently I'm showing here is it is the sidecar way. The sidecar way is very easy. For example, I push this configuration part of my OpenTelemetry collector image. Is it the same exact configuration? I didn't change anything. So with that, I packed my image. I just using that image. And here in my Java application, I just, there is a one component we have to do, sorry, I think this one. Okay, in Java, one thing we have to do, we have to run with the Java-agent with the OpenTelemetry jar. That portion, I think I didn't put here. Yeah, so only one thing we have to do by default, this all is a default port. Just we have to, you have to add one more parameter if you are running a Java application that is called Java-agent, and you have to pass the OpenTelemetry jar. And whatever ports we are using here, it is the default ports we are using. So it means that you no need to do any configuration on the application side, just the OpenTelemetry collector will do. So the OpenTelemetry collector, it is growing very fastly. It can do auto instrumentation, majority of the languages like Python, JavaScript, majority applications, it can do auto instrumentation. Yeah. Yes, correct. So only one thing you have to do, you have to pack your application with OpenTelemetry jar. So then if you are using OpenTelemetry collector as a sidecar, then by default it will do auto instrumentation. The OpenTelemetry collector will take care of everything. No, we can, let's say, if you are running in as a container, as a Kubernetes, so we can use an init container, where in an init container, just you can download the OpenTelemetry jar, and in your application, just you will use Java options in the ENB. So it doesn't mean that while you are building your application, you have to pack with OpenTelemetry jar. Yes, correct.
The example you showed is Grafana stack monitoring your resources in GCP.
Sorry, can you come again?
What you showed is you have a Grafana stack
Yes.
monitoring your resources inside GCP.
Correct.
So, okay, so the Grafana stack, is it running in a separate VPC?
So in our case, the Grafana stack, actually it is on our on-premise. But here, if you talk about here, we have a dedicated interconnect between GCP and our network. So we talk via this dedicated interconnect. Yeah.
So what's the cost of this app? Do you have how to consider the cost of for this software?
Okay, it depends on how scale you're gonna run. But in our case, what we did, we observed our case. So we are using bare metal servers. In bare metal servers, we are having three bare metal servers. In 3 bare metal servers, we are running as a cluster. So this all components.
The Grafana we are configuring to set it up a particular cluster.
Yeah.
So whether it's like when I'm opening the corner, it will fire the cookies, or it will continuously read it.
So since you are configuring on the dashboard, in the dashboard, you might be given the refresh button, right? So it will be executed based on your refresh. And whenever you open your dashboard, it will fire once. Yes. Yeah, yes. That too, if a person opens the dashboard only. Yeah. Then another thing is, there are 2 things. One is the visualization, another one is the alerting mechanism. So if you are configuring through alerting mechanism, in alerting mechanism, you have the, in what frequency you want to run. You want to run daily once or every 1 hour, you can select that frequency and you can customize that. Yeah, correct. Might be, let me see, is that I'm having. So if you see here, you can select the interval. I put interval is 30 minutes here. So something you can see how frequently you can run. I put a 1 hour. So you can generate a notification also if needed, based on this threshold, whether we have to send alert or not. So another big advantage of using this, there are a lot of, let's say, for example, I used to monitor my GCP. There is one thing called, there are so many dashboards available. If you explore, you can achieve a lot with the Grafana stack. So this is the, sorry, this is the cloud functions running on GCP. I'm monitoring from here. We can see I created so many dashboards for the, yeah. You can, let's say, by default, if you are using cloud logging also, from the Grafana, you can use the cloud logging also here. So there are a lot of sources available. If you see that data sources, we can see connection data sources. We can see yeah, there are a lot of data sources. It's all, whatever we see here, it is all open source data sources. Even if you are using ELK also, you can visualize from the Grafana, because sometimes what will happen, few matrices will be in some other place. And let's say if you are using Loki as well as the Elasticsearch, and if you together combining these 2, if you want to bring up your SLO dashboard, it will be very helpful. Yeah, it's an open source. At this moment, we are using, predominantly we are using Mimir alerts, because the Mimir alerts is having more, because for the backend, we are using object storage. If I write a rule on Mimir, we have some automated pipelines. That pipeline will deploy the rules into Mimir. This all things will be stored into object storage. So currently, we are not using much the Grafana alerts. So still we are finding how to, let's say, because the Grafana currently we are running in a standalone mode. If you are running Grafana itself in a clustered mode, it supports some backend like object storage, then I would prefer Grafana. But currently we are using mostly Loki alerts and Mimir alerts. The HA is there, but it's a bit too hard to achieve. We have to set up the database. and we have to maintain the session. Might be it need a Redis, it need a database. It's quite difficult, I feel. Yeah, as of now, it's standalone. That's one of reason we are not using Grafana as much, but that is possible to use. Yeah, if you're using Grafana alerts, then alert manager no need.
Modify the body of the news.
Okay. So can you come again? So when you are sending the mails, you should not modify your. Okay. Okay. Yeah, I think it would be then difficult only because if you're using, let's say if you're using Alert Manager, in Alert Manager, there is something called a template. With that template only, it is generating that body. So might be, if you are able to customize that template based on their requirement, I think we can achieve that. So more, because the template also is not easily to understand. So if you are want to customize it, a little bit tricky also. Actually, they will say it's a TOML format, I think. Yeah, Go templating, correct. Yeah, so almost I'm crossing the time. Yeah, so any other questions? So mainly since you here for the data observability, so as I mentioned, still also we are in the same drive. It means that let's say majority components, let's say if it is a server or if it is a database, so all things, there are a lot of data sources, we can do that. And internally, how we are planning in our team, actually, we have a dedicated team for the data team. So they have written an inbuilt monitoring agent, I would say, where it can do the data quality check. For example, whatever data is arrived, it is on the schema is correct or not. Might be your data, might be it will be in a database or it will be in a CSV file. They writing some custom agent. So while we are running that agent will be pushing all the metrics to our platform. Let's say I received 10,000 records. Out of 10,000 records, let's say around 9,500 records are okay and 500 records are error. It means that this they will expose as a metrics, good events, something like a bad events. So with that, you can easily visualize how, in what quality you are receiving your data. So you can, from that, you can derive the percentage, let's say you can put a time series database and this thing. Like this, we have many plans. So it's all about the pushing the metrics. So it's responsible for whoever is writing that agent, we can do that.
Loki, like SIEM tools like Splunk or Elastic, let's say you have AWS CloudTrail or VPC Flow logs, right? How effectively it actually integrates with Loki. Yeah, some that intelligence to build the incident and answer, right?
But they have some, I would say, they have solutions also. Let's say, for example, for VPC flow logs, let's say if you're using in a GCP, they will suggest you to publish to might be PubSub. Then from PubSub, there is something called might be from BigQuery. From BigQuery, you can push to Loki, something like that.
Top of that, there is some APIs to read and filter it and some intelligence on top of it based on the incidents that need to build around.
Yes, correct. Might be, let's say you have to return some cloud function, something there you have to control what should happen.
Splunk and all by default use those rules.
But yeah. Might be you have to It might be it's because of the paid version they should giving those features. Yeah, in open source it's difficult. Open source, it's completely open source. Yes.
Since you are running the platform yourself, so how do you make sure that the Grafana stack works?
Sorry, can you come again?
Who is going to monitor this? You know,
Yeah.
yourself?
Yeah. So actually, we will monitor this whatever we put this platform. So as I mentioned, we rely on one component, that is the alert manager. So we monitor the Mimir component. It also having its own monitoring. It will expose the metrics. Again, we'll monitor with that same monitoring system. Let's say, for example, we have one thing called target is missing. It means that if one of the server is going down, it is not exposing the metrics. So we will get alert saying that this particular component went down.
So this kind of alert, do you run on another cluster?
So we have an alert manager that will be running in a separate. So the alert manager will be keep looking for whether we're getting the matrices. So there is two components. One is the Prometheus. Let's say in Prometheus only we are scraping all the metrics. But if the Prometheus itself going down, the alert manager will be sending alert, the Prometheus is down. So now we are relying on Prometheus. The Prometheus will be scraping a metrics from these components like a Mimir, then all other components. So this Prometheus, let's say if one of the systems is going down for me, then this Prometheus will be sending alert to alert manager. So something like interdependency, yeah. Okay. At this moment, the OpenTelemetry collector can do that. You no need to do any additional work to achieve the things. So only thing might be your log format needs to be changed on your log4j. So something like, let's say, in what format the trace ID should be printed. If you are integrating with the OpenTelemetry collector, you no need any additional library. That is that. If you remember, I mentioned we have to run our application with OpenTelemetry jar. So that OpenTelemetry jar will do auto instrumentation. Yes, correct. So there is two things. One is the auto instrumentation, or they will say black box instrumentation. That will take care of everything. In very rare cases, we have to do manual instrumentation. By the time only, as you mentioned, you have to integrate with the third library, then you have to generate traces by yourself. But OpenTelemetry collector, by default, it will do. I noticed that the majority of our majority applications, majority languages, it should be able to generate the traces by default. Yeah.
Why my current application generated a lot of logs without a trace ID? Am I able to use auto instrumentation? Trace ID. How do I link the log to the trace ID?
Yeah, that will be difficult. So I think this portion might be I will confirm, but usually the OpenTelemetry collector also can format your logs. It's not from the application, but from the OpenTelemetry collector also you can append this trace ID. But without trace ID, it would be difficult only. Log stash. Yeah. So the log stash, mostly it will do like a parsing. It will do only the, it's only for logs. So mostly they will do the parsing or transformation they will use. But the OpenTelemetry collector, the objective is mostly for the instrumentation of three things, as I mentioned. So you should be able to push metrics, you should be able to push logs, you should be able to push traces. So these three things we can achieve in single place. We can say the logic is similar to Logstash, but not the exactly same. because it's more than the Logstash.
For Loki or the Rakuten.
Yeah, correct.
Yes, yes. You have to use the Protel to select all your logs. How are you backupping all your different configurations?
Sorry.
How are you keeping the backups of all your Grafana?
So for the Grafana configs, for all other things, actually, we have proper CI/CD. For the Grafana config, actually, we just backup of it will return grafana.db, that's just one database. So we just backing up that. So mostly we are planning to expose our future goal would be, we are planning to deploy the Grafana into GKE cluster because it has the Grafana operator. Through Grafana operator, we can easily deploy your ACLs, you can deploy your dashboards. So the operator will take care of everything. So might be if you put in a config map, then that config map will deploy everything. So we have that, but at this moment, we just in the file system and we just do the backing up the file system only. No, not that much, Vivian. We didn't face the issue as of now, but before we facing issue, we're planning to shift Grafana alone to GKE cluster. I feel that will be, because the Grafana operator gives more advantage, I feel. Okay, we are reaching to the time. So does anyone have any other question? Okay, then thank you all. Thank you. Yeah, thank you.